Hello, welcome to Math for All, where everyone can learn more about math. I'm Denise, and you are watching my video on using systems of equations to solve word problems. This is another video on setting up and solving word problems, so these are slightly harder to set up than the ones in my previous video, but congrats on being here. These first types of problems concern airspeed or water current. Maybe you didn't know this, but when a plane flies, it has a certain airplane speed or airspeed, but that's not how fast it's actually going. When it goes against the wind up there in the atmosphere, it's fighting that wind, so it slows down. Its actual speed is the plane's airspeed minus the wind speed. But going the opposite way is cool because the wind speed pushes that plane faster. So its actual speed would be the plane's airspeed plus the outside wind speed. If you're rowing a boat, the same thing happens. There's a water current that either fights against you or pushes you along. All this is important for a word problem like this. A plane travels from one city to another, the same direction as the wind, and its actual flying speed is 530 miles per hour. It turns around and comes back against that wind, and its flying speed is 370 miles per hour. What is the airplane's airspeed and the wind speed? We set this up with our two unknowns, say A as the airspeed and W as the wind speed. A plus W is 530, and then A minus W is 370. Once we get this set up, it's really nice to solve because of those W's that are different signs. Using elimination, we get 2A equals 900. A equals 450, meaning that those engines were roaring at 450 miles per hour. Then it follows that the wind speed that was either pushing or fighting against that plane was 80 miles per hour. Super. After your little physics lesson about air, wind, and actual speed, we have a couple of mini economics enlightenments. There's something called a break-even point, which is where a company's expenses equals its income. Now, for a company to keep going, hopefully it sells even more, but it's good to know how many they need to sell before they start making money. Take this. I make paracord bracelets, and the materials cost me $3.50 each, but I sell these puppies for $8 each. I advertise so people know I have these awesome bracelets, and that cost me $1,872. I hope it was worth it. What is my break-even point? We'll get the two equations. First, my expenses. Materials and advertising are my expenses. Notice that the material amount is related to the number that I make, so it's $3.50 times B, that number of bracelets that I make. Then I add the advertising money. Now my income. I get $8 for each one that I sell, or 8B. Those two need to equal each other, so 3.50B plus 1,872 equals 8B. I trust you can solve this and see that I need to sell 416 bracelets before I even make a profit. The next one is still economics, but it's about investing money. If I invest $1,500 total into two accounts, one that earns 5% interest and one earns 4%. After a year, I have earned $69.50 in interest total. How much did I put in each account? Notice this is kind of the same as the ones in my previous video where one equation is about how much they add to and the second equation is the value of them. First, the how much equation. X plus Y equals 1,500. The next equation is the interest value of each. 5% times X plus 4% times Y equals the interest of $69.50. Don't forget to change your percents into decimals and remember to move them back 2 decimal places like this. This is a good one to solve with substitution. Solving for X here, put it into here, distribute, add like terms, move this over, and divide by -1/100th for Y equals $550, which was the 4% interest account. And the great news is that I put more into the better account paying that 5%. $950 into that one. That's your lesson for today. You even learned some physics and economics through these word problems. Great job. Come back soon to keep learning more about math.